Put here. Okay. All right. So we were like we have finished IP addressing, I believe. Yeah. Okay. So today I'm starting a new topic, new module, and a quick recap of the previous session. So we have just finished IP addressing. So IP addressing, we already completed this topic. IP addressing, and mainly like we in IP addressing we talked about class A address, class B, and class C. Class C, and in class B, if you remember, then initial 8 bits means the first octet represent network portion. So 8 bits in binary, 8 bits, 8 bits in binary means like your network portion, network ID, and 24 bits in binary is equal to host bits or host ID. In class C, in class C or class B, in fact, in class B, your 16 bits represent network ID and 16 bits host ID. Got permission? I think already I have given you. Let me check. If not give, okay. Now I have given record permission. Hassan, you can start recording. Okay, cool. And then we talked about class C. So here 24 bits network and 8 bits host portion. So basically IPs are in binary numbers, zeros and ones, like zeros and ones. But whenever we assign IP address to any end device or host device, then we represent or assign value in decimal. So IP address representation is in decimal, but as we all know, like computers understand only zeros and ones, that is binary. So in class, basically a and all the way like IP address means only 32 bits. So there is segregation of 32 bits. In class A, the first octet. So obviously there are 4 octets only, irrespective of the class. There are 4 octets, total 32 bits. One octet means in binary 8 bits. But in class A network, this is the network portion, and rest 3 are like host ID. So 24 bits. Host ID 24 bits. And here 16 bits and 8 bits. So 16 bits and 8 bits. And network ID in class B means initial 2 octet, and in class C initial 3 octets. Network ID, right? So and this is the default behavior. So all the way like IP address means always 32 bits in binary. So 32 bits is like 32 bits has 2 portion, network and host portion. And whenever we design a single network, then the network portion should be same, and host portion definitely should be unique. So now question for you guys now. Then I'll move to this next topic, that is, and I believe you already know all this, but still, if I write down here, let's say 191.168.1.2, and here if I write down 191.168.20.5 maybe, and here again 191.168.30.6,
The middle one you give 192.
So yes, so whether they both will communicate, all three, I mean, which two computers will communicate, whether they all will not communicate. I mean, like, and look at this IP again one more time. It's 191.168.1.2, 192.168.20.5, 192.168.30.6. Sorry, 191.168.30.6. Now the question is like whether they all are in the same network, will they all communicate or no? If not, then why not? And it's just the IP address, right? 1, 2, and 3. So what do you think? Like, will they communicate? All
No, they're not.
no?
Yeah, they
Computer
are
1 and
all
3 will
different.
communicate.
They are
Let
all
me-
different network.
Let me give the number so that you can easily tell me like whether they all are going to communicate or not. Machine number 1, computer 2, computer 3. So computer 1 will communicate with any machine like computer 2 or 3.
Will
No.
3. 1 and 3 will communicate.
Okay,
No, they're
1
not.
and 3 will communicate, 2 will not communicate. You all agree, right?
No, I don't agree.
1 and 3 will communicate, right? And 2 is like completely isolated, will not communicate with anyone. So if 1 and 3 they both will communicate, then why like they will communicate? I mean, like, if you think like computer 1 and computer 3 they both will communicate, so why like whether they both are in the same network?
They are
Both
in
in
a
the same
class B.
network.
Yeah,
Okay.
same network. Yeah.
Yes, correct. Yes,
And
good.
then number 2 is class C.
And which and what is the class of this IP? A, B, C, which class?
That's B.
Class B.
Good. Yes, class B. Because it's 191, and just to create some kind of confusion intensely, I written 191 and 1968 so that it resembles 192.168. But yes, like your understanding is good.
Yeah,
So they
it tricked me at first, but yeah.
okay, so that's good. Okay, computer 1 and 3 will communicate with each other. They are in the same network because it's a class B. Class B means initial 2 octets should be same, and this machine is completely isolated because it is in class C and it has 3 octets network portion. So this machine is completely isolated. So basically these two will communicate with each other. This one is completely isolated.
Abdul Rashid get all right. So Abdul Rashid, good job.
Yeah.
Thank you.
Okay. And the important point, I'm just writing some IP address, and you'll have to answer like whether IP is correct or not. So let me write down some IP here, and another IP also. Let's say so there are one IP number. Let me write down. So first, second, third, fourth, 5. First, like whether we can assign all these IPs to computer machines or not. Whether IP is correct, just answer first one first. 223.20.256.10. Is it correct or not? Valid or invalid?
That's not correct.
Not correct. Why?
No, because of 256.
Good. Yes. True. Not correct because 256 is not allowed. Second number, 241.126.0.1.
That will work.
Will work or not?
No, yeah, it will work. It will work.
What is the class of this IP address? To which class this IP address belongs to?
Class B.
A, B,
no, it's
C.
class A, I think it was class E, I believe.
Because if you remember, then class A means, what is the range of class A? Means first octet,
1 to 126.
correct. What is class B?
It was 128 to 191.
Good. And class C,
192 to 223.
right? And here, like the first octet is 241, right? So it's not in class C, A, B, C. At least the IP address does not belong to class A, B, or C. And obviously 241 means like beyond like class C. I mean like class D address basically. It's a class D because in class D range is 224 to 239. So at least IP address doesn't fall in like any unicast IP addressing category A, B, C. So again, this cannot be used in unicast routing, right? So you cannot use this address in unicast routing. So again, this is something like invalid. And this one, can we assign this IP to any computer like 127.0.0.1?
No.
No, that
Oh.
is reserved.
These are
Exactly. Yes, yes. This is reserved and this is loop back address. Correct. Good. And again, this is 224. So I believe you understand 224. It means again it's a multicast range, right?
Yeah.
And last one is again not like 255. Like IP cannot start with 255. So it's basically a broadcast address. So not cannot be used, right?
Yes.
Yep. Also class E, right?
Yeah, beyond class D even. Okay, all right, good so far. So now I'm just moving ahead from here, and so you all understand, I assume now, IP address, yes, like you all understand well now, like how IPs are like assigned, structured, class A, B, and C. So now I can jump to the next topic now. All right.
Good.
Okay, so here we go. So next, like once we have finished assign IP address to end host devices, then the next configuration is subnet mask. So what is subnet mask basically in IP configuration? So again, a subnet mask is a 32 bits address used to distinguish between a network address and a host address in IP address. We can understand this way. A subnet mask identifies, this one is more relevant. Subnet mask is identifies which part of an IP address is the network address and the host address. So basically, subnet mask is used to identify network and host portion in IP address. But now the question is, why do we have to give this subnet mask? Because we understand like in class A, B, C, we understand class A is like first octet network bits, class B initial 2 octets means 16 bits in binary network bits, class C initial 3 octets means like network bits. So what is the use of like subnet mask? So let me first give you an example here. I'm writing here two IPs, IP address 1, let's say, and 192.168.1.1, and then I'm writing another address 2 here, and 192.168.2.2, right? So if we look at both IPs, IP address 1 and IP address 2, so 192.168 means class C address, of course. In class C address, initial 3 octets represent network ID or network bits. Means initial 3 octet network, and this one is network 192.168.2. So if there are two computers, computer 1 and computer 2, they both are connected to a switch, a centralized device. And if we assign IP address 192.168.1.1 and 192.168.2.2, so of course they are not going to communicate with each other. They will not communicate because network portion or network ID is not same, it's different. So they both do not belong to same network. They both are in different networks. So that is why they will not communicate by default, right? We will configure routing and other configuration later on, but without routing, if I don't bring in here like any routing concept, so yes, like they will never communicate with each other. Okay, so we understand like class A, B, C. We know like network ID, host ID, right? As an engineer, administrator, we understand that very well. That IP address is of class C. Class C means initial 3 octets, network portion, network bit, not same. That is why they will not communicate. But what about this TCP/IP? TCP/IP is a protocol, is a software, a program, right? TCP/IP is a software, is a protocol, a program. So TCP/IP doesn't understand like whether IP address is class A, class B, class C, what is the range? No, it doesn't understand anything. So what happens here? We like configure another value here, which is known as subnet mask, and subnet mask. And let's say subnet mask is like 255.255.255.0, and here again 255.255.255.0 in decimal. And today I'm going to also I'm going to cover binary to decimal conversion and also decimal to binary conversion, so you will understand in proper way. But for now, let's take decimal value. So if the subnet mask is 255.255.255.0, and here again 255.255.255.0. So what happens basically? TCP/IP protocol. Let's say now I initiate traffic from here to this machine. Let's assume like ping command. Means from here I want to ping another computer. Ping, and pinging means like sending some echo message, echo request packet. And if everything is up to the mark, network is like in place, like there is proper network connectivity, so definitely we would get echo response, echo reply packet back from the destination, right? And that verifies IP connectivity or reachability. So now what happens? Like after typing this command, like IP and then this one, IP and then address 192.168.2.2. From here, TCP/IP protocol will first look at subnet mask number value here, right? And why? To find out, identify network portion of IP address, whether initial 2 octets or 3 octet or first octet represent network portion. So to know that, to get that answer, to know like to identify network bits and host bits of IP address, subnet mask is checked first. So here in this scenario, subnet mask is 255.255.255.0. Means the 3 octets 255 and the 4th octet is 0. If when we convert this value in binary 255, so it is equivalent of all ones like this, 8 ones, then again 8 ones in binary, 8 ones, right? If we convert 255, so 255 is equivalent of 8 times ones, 1 1 1 1 1, and then again 1 1 1, and then 8 zeros here like this. So TCP/IP protocol, like a software, counts number of ones like in the subnet mask and number of zeros. So number of ones is equal to 24 ones. Or simply you can understand there are 3 octets have 255, 255, 255, and the 4th one 0 only. So network ID is equal to number of ones, or number of ones is equal to network ID, and number of zeros is equal to host ID. Let me put it in simple word first, and then I will just explain this. Let me show you here first. Let me quickly show you, and then I will talk about this. Okay, so now you understand IP address. So here, if I assign IP address 192.168.1.1 and to this machine IP address 192.168 and 2.2, for example, just ignore this one. I'm not going to use this one machine. Okay, only two computers, right? These two computers. Now, there are two machines, 192.168 1.1, 192.168.2.2. So you understand, like, they both will not communicate with each other. Computer 1, computer 2, they both will not communicate. Why? Because class C address, initial 3 octets is equal to network portion, network ID, not same. Definitely, they both will not communicate with each other. These two computers, sorry. And even if I just quickly, let me show you also critically. So if I assign here IP address 192.168.1.1 and this machine 192.168.2.2, 192.168.2.2, so they both will not communicate. So if I try to communicate from computer 1 to computer 2, this is command prompt of computer 1. If I try to ping is like a command to verify network reachability. So if I try to ping this 2.2, and 2.2 means now I'm trying to send echo request packet to this machine. So computer 1 will send echo request packet to this machine. After sending one packet, this end device will wait for a specific length of time, whether like response received or not received, then will show like something request timed out, or RTO in short. Also, we use the term RTO, request timed out. And if like they both are communicating, so definitely would get response like reply from, and then 192.168.2.2. Because echo request packet means like if there is proper network reachability, then request messages are always acknowledged, right? Responded with another message, echo reply packet. Now, if I hit down enter key here, enter, and see the result, they both are not communicating, and we understand, we know the reason, right? Now, you all understand like IP addressing very well. Even I tested your knowledge also, so you all understand at least IP addressing. So as expected, we didn't get any echo reply message back. So 4 packets sent.
So what was the reason that they're not communicating? Because they both have a
In different
class
network.
B, class B.
No,
Class C. 19.
yeah. No, not
192,
class
yes,
B.
you're right. Yep, you're right. Yep. Okay.
So that's why they are not communicating, right? Class C network and
Yes.
initial 3 octets not same. That is why, right? So
Yes.
4 packets sent, 0 received, packet lost 100%. There is no reachability. Now, so we understand like IP address, class C address, class C 3 octets is equal to network ID. Network ID should be same on both computers. So here network ID is 192.168.1, 192.168.2. That is why they are not communicating. But basically, when I initiated this ping from this computer 192.168.2.2, behind the scene, what must have been happened behind the scene? This PC1, because we are on here like first machine. So the TCP/IP protocol, the software stack, must have checked subnet mask, right, to identify, to find out network portion. We understand, we know class C address, initial 3 octet, network portion, but not the TCP/IP protocol. in configuration. So what TCP/IP does, TCP/IP first look at the subnet mask. So if you have like noticed, then after like putting up IP address, another value automatically auto-filled value like the subnet mask 255.255.255.0 on this machine and also on another computer. So TCP/IP first looks at subnet mask. What is subnet mask? Subnet mask is 255.255.0. So if it is converted in binary, so all ones means 24 ones, basically 24 bits ones and 8 bits zeros. Because IP address is always of 32 bits. So when we add both numbers, so result should be 32. So in subnet mask, there are 8 zeros, 24 ones, means 24 network bits, and that's correct, 24 network bits, initial 3 octet network bits. Now, look at this now, and then I'll be back to this theory part. Again, I'm going to, let me change this. So I'm back to this configuration. And if you look at this subnet mask value, auto-filled, right? I have not specified this value, auto-filled, and auto-filled value is known as default subnet mask. This is known as default. So we use a term in networking, and that is default. Default means as per the classification. So if IP address is from class C, then this is the default mask. In class A, default mask is 255 first octet, 255 network portion, and then 3 octet. In class B, this is the default mask, and class C is something like this. This is the default mask. And the question here, can we change this default subnet mask? Yes, we can change. Right? This subnet mask can be customized. We can change this subnet mask value. And by doing that, by changing subnet mask, even we can like maybe we can tell this computer precisely like TCP/IP protocol to match only maybe 2 octets, right? With the help of subnet mask. If 2 octets matching, then yes, communicate, means like same network. So let me quickly show you first, and then again I will talk about this mask in detail. So now what I'm doing, I've changed the mask to 255.255.0.0, means only initial 2 octets, now network portion, initial 2 octets. And how TCP/IP knows that? So TCP/IP will again look at subnet mask. In subnet mask 255.255 in binary, 16 bits ones, 16 ones means 16 bits network portion. And again, if I do the same here also on this machine, and now we are breaking the rule, right? We are breaking the rule of class ABC now.
Yes.
Okay, so now I did this, and see here, let me initiate same again. And look at the output now. Understood like why it happened? We got the response back from the machine, right? Class C address, and initial 3 octet is equal to 192.168.2. And first machine, if you look at the first machine, then initial 3 octet 192.168.1. So as per the like classification, as per the rule, definitely they should not communicate with each other. But see here, particularly, they both are communicating. Why? Because with the help of subnet mask, we instructed TCP/IP, we told TCP/IP to this machine that only 2 octets represent network portion. Only 2 octets, not the 3rd octet, right? So this way, even though like they both are in different like class C, only 2 octets are matching, they are communicating, they are in the same network. And let me quickly jump to this file again, and probably now you will understand the meaning of this second line. Let me highlight this. A subnet mask identifies which part of an IP address is the network address and the host address. It means at larger picture and precisely over the internet, if IP, let me take one example quickly, because understanding this subnet mask is again very, very important, right? So now let's say IP address written here 202.15, maybe 16.1, another IP address 202.200.1 simply, right? IP address assigned to one machine, IP address assigned to another computer. And if someone asks me whether they both will communicate or not, IPs, I mean, like they in the same network or in different network, right? So basically, without knowing subnet mask, question cannot be answered. No way to answer this question now. So now if I ask like two IPs, 202.15.16.1, 202.100.1, will they communicate with each other? If we assume default subnet mask, default means as per the class. So IP address 202 means class C address. And in class C address, initial 3 octets network portion. Initial 3 octets network portion means subnet mask will be in decimal like this, will be like this. So if we use default subnet mask, so definitely they both will not communicate with each other. But what if we are not using default subnet mask, right? Not the default subnet mask. If I'm using mask like this, yes, now they will communicate. Why? Because with the help of subnet mask, what we have told like that only the first octet is your network ID. Only the first octet. Match the first octet. Matching, yes, you are in the same network then. You both should communicate. Forget about second, third, and fourth octet. Why? Because subnet mask is this 255.0.0.0. So do we use like manipulation of subnet mask? Yes, 100%. Over the internet, 100%. Over the internet, we never use default subnet mask. We use custom subnet mask, a different subnet mask, right? We never follow this method. I mean, like class A first octet network. Yes, that is only for the baseline to understand like what would happen without manipulating subnet mask, default subnet mask. But and why do we do that? I will explain that later on in subnetting section. You will understand why do we change the subnet mask? Why we don't go with the default subnet mask? There is a reason for doing that, right? I will just explain that. Why do we do that? Why do we change subnet mask? Yes, we do that. And over the internet, 100%. We never use default mask over the internet. In private network, in your local area network, in your enterprise network, probably you may go with default subnet mask, no problem. You can change subnet mask in your private network also. But over the internet, 100% you will see their custom subnet mask, not the default subnet mask. So what I want to conclude from here, from the very first slide, that both IP address and subnet mask both are important in IP configuration, right? Whatever IP we write down here, without subnet mask is not of any use. If I don't tell subnet mask, I don't mention the subnet mask of IP address, and straight away if I ask like here, like there are two IPs, let's say 10.15.16.1 and 10.0.0.2. So I know like both IPs are from class A. Class A means like the first octet network portion, but not necessarily mask would be default. Maybe subnet mask this. Yes, that is possible. So if the subnet mask is 255.255.0.0, now this subnet mask breaks the rule. Rule means now initial 2 octet network portion, and they both are not same. They will not communicate. If I change the subnet mask to default, yes, they will communicate. So in subnet mask, 255 means network bits. First octet 255 means first octet network bits. 3 octets 0 means 3 octets host portion. In subnet mask 255.255 means initial 2 octets network portion. And if we convert 255 in binary, so equal to this 8 ones, and then again 8 ones. And how we do that, I'm going to tell you that also, how we write it down. So that's the way how this subnet mask is used. And now I believe you would mean this point. I mean, like if this one, a subnet mask, it is in binary 32 bits, same as IP address, right? Written in decimal, but this mask identifies which part of an IP address is the network address and which part of an IP address is the host address, right? Now let me go to the next slide. Number of ones in mask represent network bits, number of ones in binary, and number of zeros represent host bits. So if let's say you don't know like how to convert IP address and subnet mask, so if you open up calculator program calc, let me open this. Okay, so it's loading up. So I'm going to show you. So select from here like this one, programmer, this one. And here like you see like if you select this decimal and you type anything, then automatically will be converted to binary. So what I'm going to do, I'm going to type here 255 and see here at the bottom. So 255 decimal is equal to in binary 4 times ones and then again 4 times ones, right? So decimal representation is 255 means 8 times ones. So what happens in subnet mask, number of ones like counted. So if the subnet mask is this, so if I have to write down this subnet mask in binary, so its binary representation will be, this binary representation will be like this: 3, 3, 6 to 8, again 3, 3, 6 to 8, 3, 3, 6 to 8, and then 8 zeros, like this. It's binary representation, right? So in binary representation, total there are, if you count, then total there are 24 bits, means 24 ones and 8 zeros. 8 zeros. And number of ones in subnet mask represent network bits. So the same rule, I mean, 24 bits means 24 network portion. But what if I change this? Maybe I just put zeros here. So yes, now 16 bits network. So only 16 bit would be like network portion. Means with the help of subnet mask, we can change network and host bits of an IP address, right? But we'll have to understand like the concept, the reason why we would ever do that, why we would like change the subnet mask. Of course, there has to be a valid point, a reason for doing that, and I will explain that. But for now, I want to make you understand like what is subnet mask. So subnet mask means a decimal value, and this subnet mask can have like 255 and some other numbers also, right, in subnet mask. And if we convert decimal into binary, so number of ones means network portion, number of zeros means host portion or host bits. And then we again go to IP address, we try to match the IP address, matching or not. And there are two types of mask. If in computers, right, in computers, if you do not specify subnet mask, then default subnet mask is used. And default means as per the classification. In class A, first octet network, class B, initial 2 octets network, class C, initial 3 octets network in default subnet mask. But why we would be knowing all this? Because in Windows computers, yes, there is concept of default subnet mask. But whenever we configure network security devices like firewalls, routers, or some other devices, right? So as such, there is no concept of default subnet mask. After writing down IP address, you will have to specify subnet mask, right? Subnet mask is also known as, in some vendor, net mask or just mask, one of the same thing, right? Either mask, net mask, subnet mask, one of the same thing, right? So don't get confused, because this may vary from vendor to vendor. In some vendor, we find like a net mask command or net mask. In other vendor, just mask or subnet mask, right? So in Windows computer, yes, it's very easy. Whenever you type IP address, subnet mask is auto-filled, and auto-filled as per the class of IP address, right? So if you specify here class A address 10.1.1.1 and don't do anything, let's say I just hit down enter, auto-filled, right? Auto-filled means if we, sorry, go to this, set, save that, okay, and see here. What I did, I just pressed tab key from my keyboard, tab, or mouse, just click with your mouse, auto-filled value. So this auto-filled value is what? Subnet mask, default subnet mask, basically. This is default subnet mask as per the class. But the same method doesn't go with like routers and other devices. So default subnet mask only with Windows-based computer. So what if I take another device, maybe later on, like we'll be configuring this device like router or maybe some firewalls, some other devices. So whenever we assign IP address on firewalls or routers or some other network devices, then there is no concept of default subnet mask, right? If you don't mention subnet mask, you just assign IP address, immediately an error message will be generated. You will get an error message that command is incomplete, right? And quickly, let me show you the error message only. And we will understand like how to, like what all commands I'm running here. So not to worry with that. So I will explain that later on. What is the mask? Okay. 0/0. Okay, cool. Okay, so now I am typing here address here 192.168.1.1 and see here incomplete command. So here like there is no concept of like default mask or auto assignment of subnet mask, no, right? And that is why we need to understand subnet mask. So now here, if I type IP address 192.168.1.1, and again here 255.0.0.0, yes, will be accepted. Means the first octet now will represent network portion. So can we assign any value in subnet mask? No. Again, there is some rule here. For example, if you try to assign mask like maybe 245.0.0 and then 191, no, it's invalid, right? It's invalid, bad mask. So we are not free to choose any number here, right? There are certain values that we can take. But how do we know that? Because we can use 0 or maybe 128, 192, 224, right? 240 or even 248, 252, 254, 255. These values are only accepted in subnet mask. We cannot take any number, any value in the subnet mask, right? Here I tried to assign 245 and see here the bad mask, in fact, not like the valid number. So, but rest assured, like you'll understand all this concept. But my point here is to make you understand the role of subnet mask. So, for what purpose, for what reason subnet mask is used in IP configuration? So, subnet mask is used to define network portion and host portion of an IP address, right? So, protocol first looks at subnet mask, right? Counts number of ones in subnet mask and then map network ID accordingly. Number of ones is equal to network bits. So let me go back to this. Okay. So default subnet mask is the number of bits which is reserved by the address class. So default is as per the class. Using this default mask will accommodate a single network subnet in the relative class. So if we want to go as with the classification as with the class rule, then definitely we would use default subnet mask. And even in Windows based computers, if you do not specify mask, you just assign IP address, subnet mask is automatically assigned as per the class of IP address. But on other devices like routers, firewalls, some other network devices, there is no concept of default subnet mask. There is no way to assign subnet mask automatically. We as an engineer, administrator would have to specify both IP address and as well as subnet mask, both. Even if we want to go with the class of IP address, still mask need to be specified by the engineer, by the administrator. And custom is something we don't want to go with the this default class rule, right? Let's say I want to assign mask like 255.0.0 and IP address is from the class C. Yes, that is possible, but not known as default mask, custom subnet mask, custom, because we have changed, we have broken the rule. And here, if you look at the mask, default subnet mask. So default subnet mask means class A network 255.0.0.0, class B 255.255.0.0, class C 255.255.0. And in day before yesterday, we talked about this class C, that if you have more than 254 computers, so you cannot use class C, because in class C, initial 3 octets, network portion, last host portion, first IP, and the last IP, both are reserved. So basically in class C, there are only 254 valid IPs, valid host addresses in one network. So if there are more than 254 computers, so either we will have to use class B address or maybe class A address. In class B address, you see here like 65,534, and in class C, like almost 16 million or so hosts per network. And now, if quickly if I give you the reason like why we change the mask, why we don't always go with the class rule, why we change subnet mask. So before just jumping to the next slide, let me take one more example so that you can understand this concept very well. Okay, so if you remember, so day before yesterday, we talked about private and public IPs, private IP and public IP, private and public IPs. In class A, if you remember, then we like understood like this whole concept, like any address 172.16 to 172.31. And in class C, 192.168 and then any number. They all are what? Private IPs, means non-routable over the internet, cannot be used over the internet, but they are absolutely free to use. We don't have to ask anyone. We don't have to take permission. We don't have to take like these IPs on lease. We are free, right? We can use private IPs freely in our network. But public IPs, no, they are not free, right? They are not free. They are basically globally unique addresses, globally unique, not free to use, and they are provided by internet authorities, maybe by local service provider of your country or city or continent, region. But public IP is not free to use, right? And very limited IPs. You understand, because initially, like 30-40 years back, when networking came into got very popular and came into existence. At that time, like generally IP means like networking devices, right? IP address will be assigned to computers, servers, maybe some networking devices, routers, firewalls. But nowadays you see like IP means is everywhere, right? IP address is assigned to your home appliances, IoT devices, Internet of Things, and some other home automation appliances, right? Plus mobile phone, your tab, and whole bunch of devices nowadays, right? And if they are communicating over the internet, then IPs need to be unique. And we have limited IPs, right? Because if IP address is of 32 bits in binary, so forget about the reservation, forget about like other limitations. So even if we exclude everything, still there cannot be more than 2 raised to the power 32 IPs, right? Whatever value comes. So that's maximum number of IPs available. Out of that, some IPs are private, public, reserved for some other purpose, research, class D, class A, B, C. So a lot of reservation. Means IPs are limited. IPs are limited. Devices are growing day by day. IPs are not only required for computers, laptop or desktop or servers, even the IPs required for your IoT devices, other appliances or devices, right? Because without IP, they would never communicate with each other. And IPs are limited. We cannot waste IP, right? Now, let's say here is your enterprise network. So you have some, like computers, like, and let's say they are completely isolated from the internet, and you don't want them to be accessible from the internet. You want to keep them separate, keep them isolated from the internet, right? Maybe a very secure servers. But at the same time, you have maybe 2, 3, or 4 other computers or servers, and you want that these 3 or 4 servers would be accessible from internet, right? Via internet, anyone from internet side should be able to access these servers or resources, right? So here, like, you have servers are different resources, and you want to make those resources publicly available over the internet. So for that, either you assign IP address directly to these computers, or just do some other security related stuff like hide IPs of these servers, and I will tell you later on how to hide real IPs. But at least you need to have 4 public IPs, right? No matter whether IPs are directly assigned to these computers or assigned to some firewall or some other devices, and servers are like protected behind the firewall. That's something related with the security part. And we'll discuss that later on in the security section. But at least you need to have 4 public IPs, right? So this organization, let's say company ABC, organization ABC, will have to contact local internet service provider in that city or region, right? And organization ABC will contact the ISP, will ask for 4 public IPs, right? That like obviously local ISP will charge for those IPs. Nothing comes free nowadays. So ISP will ask for the money that if you are taking 4 IPs, public IPs on lease, then every month you will have to pay like some amount, right? Let's say organization ABC, company ABC agrees to pay that amount in every month. So yes, IP address will be provided, and those IP addresses will be used and definitely would be globally unique. Now, we have like studied about 3 different classes, class A, B, and C. That's fine. Class A, class B, and class C. Very high level, like from very high level, we understood that class C is the smallest network. Smallest network means in one network there are total 254 IPs in class C network. So class C is what? Smallest network, right? Smallest network. In one network there are maximum a total 254 IPs in class C. Class B is big and A is very big, right? Even class B, like there are like 65,534 IPs in single network, right? Now, what is the problem here? Problem is you approached local service provider that I need to have 4 public IPs. Obviously, service provider will choose class C. Why class C? Because class C is the smallest network, right? And will provide 4 IPs. Let's say 4 IPs like provided by the service provider, like 201, 15, 16.1, 2, 3, and 4. 4 IPs. Still, there are 250 more IPs remaining in the same network class, because class C network total 254 IPs. 4 IPs assigned to a customer, a client, a company. In the same network, there are 250 more IPs, and those IPs literally cannot be used. Why? Because 2 organizations can never be in the same network. This is organization ABC. And let's say there is another organization, company XYZ. XYZ requirement is 8 public IPs, right? And ABC requirement is, let's say, 4 public IPs. They both approached a local service provider. Here, a local service provider, internet service provider, cable modem provider, broadband internet provider. Now, service provider decided to provide IP address to this ABC organization from class C network. And let's say the available IP, the free IP that is with local service provider is from this range. Let us assume. So local service provider assigned 4 IPs from this network, 3 and 4, to ABC company. Now, next, XYZ again approached local service provider, right? They both approached basically 4 IPs provided are assigned to ABC. In the same network class, still there are 250 more IPs, right? IPs like 202, 15, 16.5, 6, 7, and up to 254. And you understand, like the first and the last both are not used, right? So now 4 IPs used, still there are 250 IPs, but 8 IPs cannot be assigned from the same network class to another organization. Why? Because ABC organization like 2, 3, 4 and XYZ, they both cannot be in the same network because different entities, different companies, right? You understand, right? different companies, different entities, they can never be in the same network. So that's a very big challenge for this local service provider. Either service provider will insist ABC that, sorry, I cannot provide you 4 IPs. Take entire 254 IPs. Again, useless. Why would ABC pay for 254 IPs? There is no requirement of 254 public IPs, right? Because public IPs need not to be assigned to all end host devices, right? Public IPs are assigned to firewalls or maybe your routers or maybe servers that are publicly accessible. Other computers, they will be running on the private IPs, and we configure some like network address translation, technically known as NAT. So with the help of that, we just like make that communication happen. I will explain that later on. Forget that. So the question here is, if local service provider is not providing 1, 2, 3, 4 IPs, asking about the entire class C address, so for organization, useless. And if local service provider has assigned 4 IPs and other 250 IPs are unused, so again, like this is something will like in fact led to like a depletion of IPs. I mean, like IPs will already we are running out of IPs, right? We are short in public IPs, okay? And in this way, if like IPs are going to be vested this way, 4 IPs assigned and 250 IPs vested, never used. So you understand, like if it was the case, then the IP would have been like exhausted long back, 10, 15 years back, in fact. So there has to be some mechanism, right, to address the problem. There has to be some solution to this problem, because this is something really the very serious problem. Because organizations, companies, hardly they would require 4, 15, 16, 18, 20, 30 IPs. And in class, in IP address, we have only 3 classes: class A, class B, and class C. Class C is the smallest network, but still 254 IPs. Class B in a single network, 65,534 IPs. Now, if service provider assign IP address from the class B to a customer, let's say 100 IPs. So what about other IPs? 534 minus 100 IPs assigned is still 65,434 IPs. Will they all be vested? If we don't get to any any solution of this problem, so definitely will be vested, right? So problem here is what? Like 3 classes only: class A, B, C. Class C is the smallest network, 254 computers. Class B is like in between A and C. A is very big network. So what we do then, over the internet, we divide this network, maybe class C network. What we do, we divide this network, logical division of a network, into a small networks, right? This class C network, a network of 254 IPs, further divided into a small networks. Maybe a very small network consisting of, let's say, 6 IPs only, or maybe 60 IPs, or maybe 30 IPs, like this, right? Further division. Why it is done? To minimize wastage of IPs. To minimize wastage of IPs, right? Because the public IP, let's say class A IP, it is with the ISP. ISP has only class A address now remaining. So class A IP means like 15, 16 million IPs. So you understand, like if 4 or 10 or 20 or 30 IPs assigned to any customer, so what about remaining IPs? Will they all be wasted? No, not at all, right? Because we have limited number of public IPs. Already we are running out of IPs, and that is why there is another version of IP address, and that is IP version 6. Right? We are studying IP version 4. We'll also study this IP version 6 later on. And just because of the reason that IP version 4 is in binary 32 bits, and this IP version 6 in binary 128 bits. Right? So IP version 6 came just to address this problem. Like the problem that we have means like we are running out of IP version 4 addresses, very limited addresses, because public addresses means like globally unique, right, over the internet. And since IPs are not only assigned to nowadays computers, so already like in at very fast rate, like IPs are getting exhausted. So whenever we do that, I mean, like when we divide a network into multiple small networks, right? And this small network is basically known as a subnet of a network, and technique is known as subnetting. Technique means like the method that we use to divide a network into multiple small networks. That technique is known as subnetting. And a small network, this small portion is a subnet or subnetwork. So when we do all this, when we divide a network and do subnetting and all that, so what happens? Subnet mask would never be same then, right? You may find subnet mask like this even 224, maybe 255, 255, 255, 252, maybe subnet mask 255, 255, 255.192, right? Not of any class even. Yes, we see like these subnet masks over the internet. So why like we use custom subnet masks? Whenever we do like subnetting, when we do I'm like, let's call division of network into multiple subnets, definitely subnet mask would get changed. You will not see the default subnet mask. So this is one of the main reason why we use custom subnet mask, right? Custom subnet mask, because as such we don't have like 100 or 200 classes of IPs. No, total there are 3 classes only. So even if, let's say I want to set up a very small network of maybe 8 computers, and if I assume that I'm going to use public IPs, so the only option that I would have would be class C network. But still class C means 254 IPs. I have only 8 requirement of 8 IPs. Still I'm going to waste like too many IPs. And what about class B and A? Let's say you have requirement of 300 IPs, public IPs. You cannot go with class C. Class C means 254. You'll have to go to class B if you have choice then. And class B means 65,534 IPs in a single network. But you have 300 IPs. So 300 IPs you will use. 65,234 IPs is still remaining. But since the IPs are from the same network, so cannot be used anywhere then. 2 companies, 2 organizations can never be in the same network. That's the problem. That is the problem. It's like we are going to waste like too many IPs. Not possible, in fact, right? Can never be done and never done basically. And that's where like this subnetting and custom subnet masks all come into picture. So yes, over the internet, we always use custom subnet mask. We never use this default subnet mask. In private network, internal network, yes, we may go with this default subnet mask as per the like classification A, B, C. But over the internet, we always go with this custom subnet mask, right? So now this subnet mask, you understand, like plays very, very important role, because just looking at subnet masks will tell us like network and host bits. And that's why in the beginning I said that if you say like, okay, I have written this IP, I've assigned, let's say, what do you call it? Let's say you said like I assigned 130.15.1.1 IP to one of the computer, and I assigned 115.5.2 to another computer, and they are not communicating. IP is correct or not? So what, as an instructor, what I would do, I will ask you, please tell me subnet mask. What subnet mask you have assigned against this IP and this IP? If you tell me that I'm using default mask, then definitely my answer would be yes, they should communicate, right? But if the subnet mask is not default, let's say you mention that subnet mask that you are using is 255.255.255.0. So obviously they will not communicate. Why? Because initial 3 update is equal to network portion and not same. That is why. So that is why in networking, in network devices, IP address without subnet mask is not of any use. Incomplete information. So whenever we like talk about IPs anywhere, we always mention subnet mask. Always mention subnet mask, right? Means IP address and then subnet mask. IP address alone is not of literally not of any use, no significance at all, right? So whenever we mention like IP address, let's say I said IP, then subnet mask, yes, mandatory. It's mandatory to mention, to specify, even if you are using IP and mask in documentation, creating or preparing any report, anywhere in any your project or network design, anywhere. So both go hand in hand, IP and mask, both are equally important, right? But sometimes what we do in writing, even in some devices, we also get the option to specify mask in different way. And what is different way? Let me first write down one IP address here. So we understood like if IP address is 192.168.1.1, and if I take the example of default subnet mask, so its default subnet mask is 255.255.255.0. This is the default mask. If the mask is converted in binary, so 255 means 8 ones like this. Again 255 means 8 ones, and 255 means again 8 ones. In Palo Alto firewall, right? Even in FortiGate firewall, in some routers, switches, other networking devices, even what we do, we specify subnet mask in different way. And what is the way? Slash and then /24. And what does 24 mean here? So it's same as specifying mask this way. So basically /24 means 24 ones, means 24 network bits, and remaining 8 would be host portion. So it's another way of mentioning subnet mask, and very popular method, very common method nowadays, right? In firewalls, other devices, we do not write down subnet mask this way, not expanding like 255.255.255.0. No. In computers, yes, we always assign mask like this. It's one notation. But in networking devices, we get option to specify network bits or maybe slash and then the value. So if let's say if I write down here any let me write down IP here 172.16.15.1/16 means 16 ones, means 16 bits network portion. So 16 bits of this IP address represent network ID and rest 16 host portion. If here the value is 8 means first octet 8 bits is equal to network bits, remaining 24 host bits, because total is 32 bits. So it's another way of mentioning or writing down subnet mask. So do we have to know both? Yes, right? Because if let's say you have finished your CCNA and later on, maybe after 6 months or a year or so, anytime, if let's say you are interested to get into security domain, cyber security, network security, firewall. So in most of the firewalls, we get option to specify mask this way only, slash and then some value, right? Not like writing down 255, 255, 255. So you should be knowing both the ways, right? There are two ways to define subnet mask. So in some platforms, we get option, either this or this. In some platforms, we don't get option. The only one way, either writing down in decimal like 255, 255, or just specifying network bits like 8, 16, 24, and so on. And we use a different term for that, classless internet domain routing, CIDR notation or format. So it's just a notation or format, the way like to define network and host bits. So let me go to this. Okay. And this I will make you understand, understanding the powers of 2. So powers of 2 are important to understand and memorize for use with IP subnetting. So subnetting is the next module. Probably tomorrow we'll start subnetting. When you see a number noted with an exponent, it means you should multiply the number by itself as many times as the number. So it's just like preparing you for subnetting, because in binary, if let's say I have written 2 raised to the power 3, 2 raised to the power 3 to the power 3, for example. It's a simple mathematics. So this means 2 into 2 into 2, the number itself multiplied. So 2 into 2 means like 4, and then 2 means 8. So 2 raised to the power 3 means 8, right? So like generally in networking, we memorize like these values. I mean, like if I start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe 10, 11, 12, and so on. So power 0 of any number, right, means always 1, right? No matter what the value is. Like, so here also we start with 1, and 2 raised to the power 1 is again 2. 2 raised to the power 2 means like 4. 2 raised to the power 3 means like 2 into 2 into 2, 8. And 4 means like 4 times, again is 16. So this way 5 times. 5 means 2 raised to 2 multiplied 5 times. So 32, and then 64, 128. So this way, like we memorize like 1, 2, 4, 8, 16, 32, 64, 128. So this is like your 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, 7, and 8. So 2 raised to the power 8 means 2 multiplied by 8 times. And if you get confused, like if you're doing practice and you get confused, then you can always use calculator. So calculator will help you out. And probably, let me see, like if I can show you, where is calculator? Have I closed that? Okay, I need to open it again. Because in networking, like 0 and 1's like very powerful. So this time what I'm going to do, I'm going to change this to scientific. And let's say 2, and I believe this one raised to the power 8 is equal to, and see here 256. So what I did, I used this function, right? Let me show you again. So what I'm going to do first, I'm going to click this 2, and then power. Let's say I want to figure out like the value of 2 raised to the power 5. So what I will do, I will first click 2, and then this x to the power y, and then 5, right? So look at the calculator here, 2, and then I'm going to click here x to the power y, and then see here like it's mentioned here 2 raised to the power, and then I'm going to click 5, means 2 exponential value 5. Obviously I know the answer would be 32, right? So 5, and see here, so 32. So that's the way how it is computed. So 2 raised to the power 5 means 2 multiplied 5 times. 2 multiplied 5 times. And really it's very, very important because this way, even if another interesting point I tell you. So let me be to this page only. So now see here, if I have written any decimal value or binary number, let's say if I write down, I'm telling you binary, first binary to decimal conversion without using calculator, right? Calculator is one way, but without using calculator. Let's say binary number here written 0, 1, 0, 0, 0, 0, 1, 1 is a binary number. Total how many bits? 8 bits total. Here if you count number of bits, then total there are 8 bits. 1, 2, 3, 4, 5, 6, 7, 8, right? And now let's say if I have to convert binary into decimal value, right? Without calculator, without using a calculator, then yes, easily I can do that. And what is the method? And the shortcut method is write down values like this way, like the same like as we computed 2 raised to the power 0, 2 raised to the power 1, 2, 3, and so on. So value, if you remember, so value was 1, 2, 4, 8, 16, 32, 64, 128. It's like position value corresponding to bits from right to left. I moved from right to left this way. So it's position value 1, 2, 4, 8, 16, 32, 64, 128, and how it is computed. So value corresponding to 0 will get cancelled. 0. Any value on top of 0. Value 0 on top of 0 cancelled. And value on top of ones, add them together. So on addition, after adding like all three, means 128 plus 64 is 192 and plus 2. So this is what? 194. Right? I have like converted binary to decimal. So what is decimal value? 194. Right? Remember what I use? 11000010. Let me take another example. Let's say if I write down only 4 numbers, 0, 1, 0, 1. Again, the same method. What is method? Write down value this way: 1, 2, 4, 8, 16, 32, 64, and 128. Right? Total 8. So 1, 2, 4, 8, only 8, 4 digits. Right? Now, value corresponding to 0 cancelled out. So here 8 and 2. So 8 plus 2, 10. So what is the decimal value? 10. 1010 means 10. And just you can do cross verification from your calculator. So again, and understanding binary to decimal and even decimal to binary also sometimes will be important in subnetting, in fact. So now if I click here binary, I have selected binary, and if type 1 0 1 0 1 0 and 1 0, so is 10, and how is 10? So the same value, just forget it. What is written here? 1 2 4 8 value on top of 0, cancelled. So 8 and 2, this is 10, right? Again, if I write down this 1 1 1 1, so position value will be 1 2 4 8. I'm taking only 4 bits now, so obviously there is no 0, nothing will get cancelled. Add them together, so 8 plus 4 plus 2 plus 1 is equal to 15. So decimal value corresponding to the binary 111 would be 15. Can we check that? Yes. So write down 1 1 1 1, right? And look at this decimal. Forget about this. This one is octal, octa, hexa. We're not interested in hexa and octa, right? Decimal and binary. So decimal is what? 15. So this binary equal to 15. So similarly, if you convert 8 ones, 1 2 3 4 5 6 7 8, so position value start from 1 1 2 4 8 16 32 64 128. Basically the concept here is like this number is 2 raised to the power 0 multiplied with 1 plus this one, so 2 raised to the power 1 multiplied with 1, and then 2 raised to the power 2 plus 2 raised to the power 3 plus 2 raised, like this, and then multiply with the number. So anything multiplied with 0 means like would be 0. Any value multiplied with 0 means resultant would be 0. So from there, like this shortcut method is derived, but you don't have to know all this. Even this shortcut method is more than enough, right? If you understand like the shortcut method, more than enough. Just write down like position value from right hand side to left hand side, move this way, and how you'll have to start with 1 2 4 8 16 32 64 and 128. And no need to go beyond this, because an octet means total 8 bits. An octet means total 8 bits. Then another next octet would start then. And how to do the computation further? So since there is no 0, nothing will get cancelled. Just add them, add all the values, right? Even like when we let's say there is another like shortcut method, and the shortcut method here is, if you add like all these values, so after adding all this, the number that you would get would be less than 1 from this only. So this value is 64, and add them together. So after addition, you will get 63, right? That's another shortcut method. Even sometime what we do, we never add even. Just at looking at the number, we understand like what would be the value. For example, here, if I have to add all this, so after addition, answer would be 127, and this one is 128. So if we add both, then 255. Means like this is designed like in such a way that if we do addition like 1 2 4, so if we add 4 2 6 and 1, and the next value is 8, so obviously the resultant value would be less than 1 from this value. Then the next one is 16. If you add all these, then answer would be 15. and 32. If you include 16 also, then 31. Anyway, like is just a shortcut method. So up to you, like how you are going to convert this binary to decimal, and why this is important. So I will take your questions. Just hang in there, just 2 more minutes, and then I'll be open to take your queries and questions, because we are almost ending this presentation file. Subnetting I will start tomorrow, but understanding binary to decimal conversion and understanding subnet mask, both are really very important. So definitely I will take your questions, your queries, and related to these two, like subnet mask and conversion. Tomorrow we'll understand subnetting in detail, but let me finish these 2 slides first, and then I will take your questions. Okay. So what is CIDR? Classless inter-domain routing. Routing term, forget it for now. I will explain this routing term later on. For now, you can understand CIDR is nothing, it's just a way to allocate, define like network and host bits, like this slash representation, this one, and look at this slide only. This slash notation, this one. So if here, like you see, like 192.168.10.32/28, /28 means 28 bits of IP address define network portion, because slash means how many bits are turned on, means number of ones. If I write down here /24 means 24 ones, 24 network bits, and maximum obviously like 32, maximum 32, all ones. We cannot go beyond that. So CIDR is nothing, it's just another way of defining or representing networks and host bits. So instead of writing down decimal value like 255.255.255.0 is another way, right? But not supported in Windows computers. You cannot use slash in Windows machines, but at the same time, you can use slash notation in your security devices, routers, right? That is possible. So yes, it was like the last slide. Now, yes, ask your questions, like anything related with binary to decimal conversion, about subnet mask, about CIDR notation. So 3 important discussion we had today, like subnet mask. Let me write down here mask, and the next one is like CIDR notation or representation. Is another way of like representing network and host base. And then we also discussed binary to decimal conversion, binary to decimal, right? So 3, and also we understand like powers of 2, like the same, like 2 raised to the power 0 is equal to 1. Basically, any value and power 0 means 1. So 1, 2, 4, 8. So this way you'll have to remember 1, 2, 4, 8, 16, 32, 64, and 128. So we will go like this, and 4 is missing here. 1, 2, 4, 8, 16, 32, 64, and 128. Yes. So you'll have to remember all this. It makes things simple, easy to understand. So today we discuss subnet mask, CIDR notation is another way of like representing network and host bits is in decimal, and this is like something counting number of ones, like slash notation, slash, and then number of ones or network bits. And in subnet mask is a decimal representation. If I write down example of both, so here is something like writing IP this, and then subnet mask 255.255.255.0. CIDR notation is something like 192.168.1.1/24. And this is binary to decimal conversion. Now, yes, questions, please. Now, anything if you still you are confused, didn't understand properly. So yes, go ahead, ask your question now. I'm open to take your queries.
No, I wasn't gonna ask a question, but I was gonna say the shortcut that you show us how to convert binaries was very helpful and very clear. And
Okay.
look, it looks good today.
And one more thing, what you should do, like in your free time, probably maybe by weekend or so, or maybe weekend probably because of New Year celebration, you might not be able to spare out time. I'm not sure. So because after 2 years, in fact, this time celebration is going to be free from COVID for now. However, in India, still there is a panic situation because China is like neighboring country, and in China there is like again a measure severe like cases of COVID again. So India since very adjacent to China, neighboring country. So here also people are in fear, but still like celebrating like New Year's and all that. So probably if you won't be able to spare out time on weekend, so but anytime whenever you get time, whenever you are able to spare out time, so I definitely recommend doing some exercises from binary to decimal conversion, and you can pick any random value and you can start conversion like this way. Let me quickly take, because really this would be helpful. Like for example, let's say if I write down 11000101333628, let me take one more example and try to convert them. Right. Yes. Can you try like converting these numbers into decimal?
I'm gonna try the first one.
Okay. Answer me.
And 128 plus 64 plus 32 plus nope, not 32. 2 1 2 4 plus 4 plus 1. So 197.
Okay. Correct. And can anyone like give a try to the next one?
I'll
This
try
one?
the second one. Yeah.
Yes. Try and answer me. Position value is for your simplicity. I can write down here 1, 2, 4, 8, 16, 32, 64, 128. Rule is same. Any value on top of 0 like will get cancelled, and value corresponding to ones will be added. So what would be this like presentation? I mean like decimal value.
I think 168, 169.
169. Let me check because I'm not also sure. So this one is 1, 2, 4, 8, 16, 32. So yes, so here like you say 169. So this one would get cancelled.
Is correct.
This one is also, this one also, this one also. So first one is 1, 8, 32, and 128. So whatever value comes, right? 128 and
32 plus
32
8
plus 8 plus 1.
169.
Yes. Correct. 169. Yes. And this one, third, is easy.
It's easy,
Yes.
yeah. 129.
129.
Another
Correct.
one is easier than this.
This one
192.
is 192. Good. All right. So that's good. Now you are prepared for submitting then. That's what I wanted, right? I wanted like you guys to understand like this binary to decimal conversion. And since you understand, so yes, we can then move to the next topic. And believe me, like the next topic is something subnetting. Even I teach like CCI also. I do take CCI and CCNP classes. CCNA classes I'm just teaching after a very long time. So generally I don't take CCNA batches. But believe me, even I take CCI batches, the last one. And 70 to 80% students of my classroom still like they struggle with subnetting. I don't know like how difficult or how like easy it is, but still, if you ask anyone like, do you have command over subnetting in TCP/IP networking? Probably like 70-80% people, like answer in negative. I mean, like that not very much comfortable with subnetting. Up to CCI level even. So forget about CCNA, even CCI guys like CCI engineers are those like who are taking CCI training classes from me or maybe CCNP. Still, they request me to teach subnetting again. So this is something like believed to be. I'm not sure like why it's so complex, but now you can like judge all this. I mean, like after taking 1 or 2 sessions, whether really subnetting is that too tough or easy to understand. But this one is like treated as most difficult topic or chapter of CCNA, CCNP at least, because other topics after this very easy, very simple. Even subnetting is also not very tough. If you understand IP addresses, you understand mask, binary to decimal conversion. After doing 2 or 3 exercises, I believe you guys would be very much comfortable in subnetting also, right? Because you all like are picking up very good. Because I started like taking your session like after assuming like you all are very new to networking, and in spite of all that, like you guys are like understanding concept very well, and that's something really I like. And even it also encourage me like to like to give my 100%, to give my full of energy. So that's a very satisfactory. And so tomorrow I believe you all are available, right? Because yesterday I was knocked down with like some mild temperature, so as a precaution, like I didn't like take your class and any other classes. In fact, so completely I was on rest yesterday. But now I'm all right. I mean, like I'm recovered. So it was just like some seasonal fever, nothing serious. So tomorrow, if you all are available, then we can have session tomorrow, right? My availability is there, so I'm also available tomorrow.
Yeah, most of us are available as per and our friends reply to the message on WhatsApp. So we
Okay.
are yeah.
All right. So if you are like okay with tomorrow's session, so yes, like definitely we would have tomorrow's session. And in case if there is any change or anyone like is not available for tomorrow, so do you can just drop any message in the group. I will be then I will do accordingly. From my side, I'm okay. Like I'm okay with tomorrow also, at least in this week, so that we should maintain like the same PS. In fact, so because I decided to take at least 3 sessions in every week, so that is why. So in this week, like we had only 2 sessions, like Monday and today. So tomorrow, like if you can manage to attend tomorrow's session, so would be great then. Because tomorrow then I will at least start basics of subnetting. Subnetting is again a big topic. We'll take a couple of classes, minimum 2 classes. So at least 1 class we can have tomorrow, and then next class next week, next year, probably next year, right? Monday would be yes. So,
Yes.
yeah.
Can you send us this and PowerPoint?
Sure. I will send this and the next one also, subnetting also. I will send this like today, and like even like PPT of tomorrow also, like the class that I would be conducting tomorrow.
Okay.
All right. All right, then.
You need